Let's now take a look at how we can price barrier options. For barrier options, we actually have 16 different possible variations. Actually, we don't have to deal with all 16 situations, and you'll see why very shortly. For barrier options, let's say as a call, you can have a situation where the stock price is lower and in, meaning the stock price gets lower, and then the option is activated. Now, before that, the option is not activated. That means the option is not really exercisable. Or you can have a call where you require down and out. That means the option, if the stock price was lower than a particular level, you don't have this option anymore. So this option becomes not exercisable if the stock price is lower than a particular value. And also similarly, you have up and in and up and out. Now, for each of those conditions, you then also need to worry about if the option barrier is greater than the strike price or not. So in this particular case here, we have the option barrier greater than the strike price. And so here is down and in. So you have to be lower than the barrier. And then, within the life of the option, the stock price has to be lower than the barrier. Then you have the option activated. But in this case, the activation barrier is greater than K. So, which means that, at the time of activation, the option is actually in the money or at the money. Now, on the other hand, if the activation barrier H is less than K, so for call and down and in, the first instance that the call becomes activated or exercisable, that call is a out of the money call to begin with. So you can see that between these two, this is a more difficult condition than this. So therefore, the same call down and in with this condition here must have a higher price than this. Okay, so how do we denote them? So we have a notation that C is for call, down and in, the barrier greater than or equal to the strike price. So if we have a put, we have a P here, down and in. And if it's down and out, we have DO. So here it can be a C or a put, a P for call or put. Here you can have a DI or a DO. Here you can have H greater than or equal to K or H less than or equal to K. If it's up and in, so it will be UI, and up and out will be UO. Now, without going into the actual math, a down and in call option, barrier option, with the activation barrier less than the current strike, less than the strike price, will take this particular form here, and with the lambda as this, and the y, which is needed here, as this. Okay. Now, suppose we know the price, given everything here, so we can calculate the price of down and in option with this. Now, so then the question is, what's the down and out option with this barrier condition? Well, you will see that it's really just the price of a regular call minus the down and in barrier option. Well, why? Well, because if you have this activation condition, the call will either be a down and in or a down and out, right? So you put them together, you actually form a regular call. So put it another way, a regular call is just basically a sum of these two options. One is down and out, one is down and in. So with this particular barrier, you either in, one is got lower, it's either in or it's out, right? Those two are complementary to one another. Now, if you look at the other condition where the barrier is greater than the strike price, and down and out call will have this form here. And by the same token that a down and in with this barrier condition will be a regular call minus a down and out call. So if you have a down and in, up and in call with the exercise condition where the barrier is greater than the strike price K here, we'll have this particular formula here. Then obviously you can calculate the up and out call if you know this up and in. Okay, so what is the price of a call that is up and in, and the the barrier price is greater than, the barrier price is less than the strike price? Or we're looking at, say, a call that is up and out where the barrier is less than the strike price. You see that in this situation where if we're looking at a up and in call where the barrier condition is less than K, less than the strike price, essentially this is just a regular call. Now the reason to see that is the barrier condition applies to the entire life of the option. But this, since the barrier is less than the strike price for a call and it's up and in, this barrier isn't really a condition or provides any more restriction than the current irregular call here. Because let's say during the life of the option, it broke through this barrier. Okay, fine. Once it broke through that barrier, it becomes a regular call. Fine. Let's say it never broke through this area during the life. Well, then value will be 0. But then for a regular call, if the stock price at maturity is not greater than this K, it will also have a value of 0. So this additional condition of this barrier that is not more restrictive. Therefore, it's basically a redundant condition. So a up and in call with a barrier that is less than the strike price it provides only a redundant condition. Therefore, it has the same price as a regular call. Now, for this thing here, where you have up and out call, and with the barrier condition less than the strike price, will always have a value of 0. Why? Because if at any point in time it has gone up to broke through the barrier, then it's 0. Okay. Now, let's say it has not gone through that because this is less than K. So as soon as at maturity, you are able to get a payoff because you require the stock price to be greater than K. As soon as that happens, then the call is out. So there's no situation, there's no condition where the call will have any positive payoff. Like, in fact, the payoff in all the situations is going to be zero. So therefore a up and out call with a barrier condition less than strike price will always have a value of zero. Now, why people trade barrier options? People trade barrier options because barrier options are cheaper than the regular call and the put, than the regular option. And by having some additional constraints there, they're hoping that the constraint would really not limiting them. And because of the constraint, the price is cheaper, so they get a cheaper price call or a cheaper price put. But they're willing to take a little bit of risk where certain constraint may kick in. Then in the case of a up and in, then if it's never get to that point, it would never be activated. So they're taking this additional risk, being additional constraint. But sometimes you see here that the so-called additional constraint, the barrier, may not really be an effective constraint. And here, this constraint is in such a way that it would just be so strong that it would never make the option worth anything. Now, I'm not gonna show the formula for the put option, barrier put option, because they're available in the textbook. Just use that and make sure you understand the notation that's used in the textbook. And what I want to point out is that if the condition we discussed before was a continuous condition, so it measures any point in time. Now, suppose you only measure that periodically, maybe a few times a day, or maybe once every few days, then you can actually adjust the formula that we have seen earlier, in which case, being not a continuous monitoring, this will make the restriction less effective. Therefore, the prices will need to be higher. And if you look at it, if you have an up and in or up and out option, you can have, an adjusted H in place of an H. And for the down and in or down and out option, you have a different adjustment for H as well. Okay, so that's basically what we have for the barrier option.